Hi everyone, today's topic is the law of cosines. This is the note packet that you'll need for today's lesson. And remember, you can stop the video at any time if you need to catch up on notes or you want to try examples on your own. If you have a triangle that is not a right triangle, we said you could use the law of sines to solve for a missing side or a missing angle. However, you had to have two sides and two angles present. Sometimes we'll have three sides and only one angle. And when that happens, we use the law of cosines. You'll notice in my triangle, I've used capital letters for the angles, and then we've used lowercase letters, same as across from the angle. So lowercase a, b, and c. This is our law of cosines. It looks a little bit confusing, but I think once we work through some of the examples, you'll find it's fairly easy to work with. What you'll notice is the first half of it looks like the Pythagorean theorem. And we've used parts A, B, and C. And then the second half is a mix of those parts, but again, we have A, B, and C. So we're basically using everybody twice. What you'll notice in the equation is that angle A, or cosine of A, and then side A are at opposite ends. This is the normal structure. If you were missing side B or looking for angle B, those would be at opposite ends in place of A, and we're going to change the structure of it as we have different triangles. Again, there's a resemblance to the Pythagorean theorem in the beginning. This structure is always present in the law of cosines. It's just that the letters will be changed around. So again, if we have three sides and one angle, that's usually an indicator that the law of cosines is going to be used. So we're going to do three different versions of the law of cosines depending on what we're looking for. The pattern of the letters will remain the same. So it's always going to start in the beginning like the Pythagorean theorem, and then the same combination of multiplying 2 times 2 of the sides, and then ending with the cosine of an angle will remain on the right-hand side. So this was the first version we looked at. Maybe side A is missing, or we're missing the cosine of angle A. But it's possible that maybe side B is missing. If that's the case, B starts the equation, and then it ends with cosine of angle B. But then A and C are in the interior, and you can see it here, 2 times A times C. It's possible you're looking for side C or angle C, so they start and end the equation. But then the interior, I have A squared and B squared, and then 2 times A times B. So this intersection uses the same values, and then the outer pieces use the same values. So it's the same structure, but you have to be aware of what you're setting up. So in example 1, they've provided us a triangle. We have 3 sides, even though one's missing, and 1 angle. So we're going to start the equation looking for side C. So we'll begin with C squared, and then it'll be equals to A squared plus B squared. Because the inner portion is the same, it's minus 2 times A times B, and then it ends with cosine of C. I'm going to fill in the pieces that I know. C squared, or C, remains unknown, but side A is across from angle A, so it's 10 squared, and side B is across from angle B, and it's 12 squared. Minus 2, and then this is side A and B, and then we do fill in 48 for the cosine at angle C. We're going to go through and solve different pieces. We don't want to get too far ahead of ourselves and try to do it all at once. So I'm going to square the 10 and the 12. I'm also going to go ahead and multiply 2 times 10 times 12, and I'm going to leave cosine of 48 alone for right now. In the next step, I'm going to add 100 and 144, but I'm also going to multiply 240 times the cosine of 48. Make sure your calculator is in degree mode before you calculate. So again, this is c squared, and we're going to subtract the 2. And now I want to take the square root of 83.4087. And I did round it to the nearest tenths because it wasn't perfect, and that is my missing side. In example 2, they give us pertinent information, but they did not draw a diagram. So I'm going to encourage you to do that before you start. So we have triangle A, B, and C. I was provided with side B, side C, and angle A, but they're asking me to find side A. So because that's what I'm looking for, I'm going to start my equation with A squared, and I'm going to end it with the cosine of A, which is 62. So here's my generic format. B and C are in the interior, same thing here. I'm going to sub in what I know. I know that B is 14 and C is 12. I'm subbing it in here for 2 times B times C. Remember, just solve little pieces at a time. So the first 2 values were squared and then multiplied 2 times 14 times 12. So again, I'm going to add 196 and 144, and then I'm also going to multiply 336 times cosine of 62, and we'll subtract those results. And then we'll square root so that we'll solve for A. And again, I rounded it off to the nearest tenths. In example 3, you can see in the diagram they provided all 3 sides, and this time they want me to find the measure of angle B. So it still fits the criteria for the law of cosines. So I'm going to start my formula with B squared, and it's going to end with cosine of B. I do know the values of A, B, and C, so I'm subbing those in. I'm going to leave cosine of B alone. If you prefer to convert B to theta as a variable, you're welcome to do that. So I've got my squared values, and I also multiplied 2 times 7 times 5. When you're looking for an angle, this is a little bit trickier. So I'm going to go ahead and add 49 and 25 to get 74. What you need to realize is that negative 70 is being multiplied by cosine of B. This piece needs to stay together. So we're subtracting 74 from both sides to get negative 10. Now that this has happened, now we can divide both sides by negative 70. So they'll cancel out on the right here. And I'm going to reduce my fraction to 1/7. Again, when you're finding an angle measure, we're going to activate our inverse cosine. So 1/7 and B are going to switch places. And I'm going to enter this into my calculator. Again, make sure you're in degree mode. And it tells me that B is approximately 82 degrees. Again, in our last example, they did not provide a diagram. So based on the given information, I know the 3 sides, and they're asking me to find angle B. I used theta this time. So since I'm looking for angle B, I'm going to begin the equation with side B. Here's my basic structure. You'll notice A and C are in the interior. There's my 3 sides correctly substituted in. Please pay attention to which side you're subbing in. You don't want to randomly mix them. So I'm going to look at each piece and square and multiply. 2 times 11 times 12 gave me 264. And again, the negative 264 is being multiplied by cosine of theta. That has to stay together till the very last step. So I'm going to add my 121 and 144. We will get 265, and then I'm going to subtract 265 from each side. At this point, we can now divide both sides by negative 264. It will cancel on the right. My fraction will reduce to 5/8, and at this point, I'm going to activate the inverse cosine, and we're going to switch places. And then I'm going to enter this into my calculator, and my angle is approximately 51 degrees. This is homework number 106. It was in your packet of materials. Please do this on separate paper. You're only going to do the problems that I circled. Once you get past problem, I believe it's 8, it asks you to complete the triangle. That means you want to solve for all missing pieces. So there'll be multiple steps. If you have any questions, please either send me an email or call me or text me. And when you finish the assignment, please send it to me either as a PDF or just send it with pictures on your phone through email. Have a great day.